Hello and welcome to another episode of CISO Tradecraft, the podcast that provides you with the information, knowledge, and wisdom to be a more effective cybersecurity leader. My name is G. Mark Hardy. I'm your host for today, and we're going to be talking about complexity and why complexity makes cybersecurity more difficult and things that we could do about it. If you're not following us on LinkedIn, please do so. We have a lot more than podcasts. We also have a regular stream of high signal, low noise information that's going to help you in your cybersecurity career. Don't forget to check us out on our other formats as well. If you're watching us on YouTube, wonderful. If not, go there and please subscribe. Also, we have a Substack newsletter you can listen to if you'd rather read our podcast. And as always, we'd love to hear back from you to know how we're doing and ideas for other episodes. Now, a common misconception in cybersecurity is that more complex systems are inherently more secure, but I disagree. The famed British computer scientist Sir Tony Hoare once remarked, there are two ways of constructing a software design. One is to make it so simple that there are obviously no deficiencies. The other way is to make it so complicated that there are no obvious deficiencies. Now, the latter approach, while seemingly robust, can obscure vulnerabilities that are hidden within the complexities of interdependencies. Now, Tony, who's in his 90s, developed the quicksort algorithm back in 1959 and received the Turing Award in 1980. So I think his advice is probably worth following. But he has some good company when it comes to observations about complexity. Leonardo da Vinci had said, simplicity is the ultimate sophistication. And Einstein had said, everything should be made as simple as possible, but not simpler. Now, another great mind, Bruce Schneier, is a person I've known for over 25 years, and he's one of the more prolific writers in our career space. And he has a reputation for speaking his mind and a willingness to entertain ideas that make you think. In one of his more recent books, Data and Goliath, The Hidden Battles to Collect Your Data and Control Your World, Bruce said, complexity is the worst enemy of security, and our systems are getting more complex all the time. Let me repeat that, as I think Bruce is onto something profound. Complexity is the worst enemy of security. Yet we do it all the time to ourselves. We keep adding productivity tools for our users, but in exchange create a vastly expanded support problem for IT. Now, the past 24 hours, our IT team dealt with users that were having difficulty with external guest access to Microsoft SharePoint sites, problems getting Teams to connect the right resources, accessing plugins in the Microsoft Store, problems with a laptop camera, installation of a particular MFA required by a client, setting up a VPN for client file transfer, getting Adobe to update properly, keeping emails from certain senders from ending up in the spam folder, and getting all the iPhones updated iOS 17.5.1. That's just one day. And for a small organization, imagine the issues faced at an enterprise level. It almost goes without saying that increasing complexity increases the attack surface. Plus, it can reduce visibility into your technology stack. If it's too complex, we can't see through the forest to see the individual trees. I think what happens is we don't think through the total cost of ownership of a new system properly. There are essentially four major costs: developers, licenses, hosting, and support. We might get all excited about a new technology and rush out to buy it. But what if it takes 1,000 developer hours to implement? Or we come up with an idea for a great website that can scale to dozens of instances, but we get killed when the hosting bill comes in. Like I just mentioned, you might have developer, licensing, and hosting under control, but the support and maintenance is a bear. Simplicity is one place, but that might spawn complexity in another. And as security leaders, we really need to think things through carefully. For example, let's say we want to build a highly available web application that runs on a Kubernetes cluster. Let's define what needs to be done to make a highly available web application at Kubernetes at a more technical level. The developer will first create a Docker container that has a base image of an operating system like Red Hat or Ubuntu Linux. Next, the developer will need to modify that container image by adding all the dependencies needed to run the custom web application. And after that, our developer will need to get Kubernetes properly working. And you have to understand kubelets and kube proxies and pods and schedulers and everything in the control plane to get things working. And if that isn't enough, we also said the web application needed to be highly available. So developers will need to create a cloud solution that works across multiple AWS regions and availability zones. Seems complex, right? Now, can we as an industry just stop doing this to ourselves? Just think of all the ways that complexity is harming security and increasing our maintenance costs. Step one is we start with a Red Hat-based container image. Red Hat-based container image is roughly about 75 megs of software. Now compare this with Alpine Linux, which is a minimalist operating system built for containers. It's roughly about 5 megabytes in size. Now we have 70 megs of software that we don't really need on our operating system, and we have to maintain that, apply the patches, and keep it going. Now think of it another way. Red Hat comes with SSH. If Secure Shell has a vulnerability, then a developer is going to have a software composition analysis tool or a container security tool saying, you need to patch this software, even if it's not running. Because most tools just look for the presence of software vulnerabilities instead of confirming if they're actually running and present a risk. And additionally, we shouldn't think of the cost of creating large systems with backups at scale, but we should, right? Think about it. 70 additional megs doesn't seem bad. But when you run the same server stack on perhaps hundreds of applications that have dozens of nodes and daily backups, it starts to sound like you have gigabytes or petabytes of data instead of just 70 megs. Step two, once we get past our base container image, we actually need to install the web application. Now, years ago, it would have been a typical Linux, Apache, MySQL, PHP, or LAMP stack, but now we typically see something like NoSQL DB, Express, React, and Node.js. Okay, so are you sure your developer is an expert at using a hardened configuration of each of these systems to get each of these correctly installed? Tell me, where, again, and when did your organization teach these developers how to perform this function? And did you document it? Because if you didn't, maybe you have a golden image that the developer can leverage, which has been blessed by the organization. You've done that, right? Or is this one of these choose your own adventure? Now, step three, we actually need to get our container hosting services in Kubernetes installed and working correctly. Our developer has to create controller manager, scheduler, API server, cluster DNS, an Etsy daemon, a kube proxy, a kubelet, and a container runtime. You also need to get things like Kubernetes role-based access control objects properly defined, resource requests and limits in place, ensure there's a proper Kubernetes storage, define the network policies, and if they get any of these wrong, you might just find some Kubernetes vulnerabilities that might be very hard for your organization to find before your next ransomware exercise. Step four, developers have successfully navigated installing Kubernetes and Docker. So they begin making the application highly available on Amazon Web Services. This means they use EC2 servers in multiple regions and availability zones that are auto-scaling and behind load balancers. And don't forget, you need to ensure our developers are optimizing the size of each EC2 instance. For example, should be a large or an XL. Should we pick one that focuses on memory, storage, GPU? Each of these decisions optimize or increase our AWS costs. Don't forget the developer should also understand that if they pick reserved instances or use spot pricing, they can also lower their costs by up to 70 to 90%. Now, what is that plan for the architecture diagrams? Step five is the custom code. Now that we have our web app running on AWS in a highly available Kubernetes environment, we can start writing custom code. Now, once you do that, be sure to scan it with a static application security testing tool, SAST, dynamic application security testing tool, DAST, and interactive application security testing tool, IAST, and put it behind a web app firewall, your WAF, and a runtime application self-protection RASP tool if you really want to be able to find the vulnerabilities and patch and keep your application safe. Oh, by the way, don't forget to implement a single sign-on solution, tools to log and monitor and alert on your application, your daily backups, and all the other things you need to ensure you check all the right compliance boxes. Now, can you see how all this complexity is just sucking time from the developer and cybersecurity departments? It's creating a significant time commitment to get everything running, and then we've introduced so many things that could be misconfigured. I have to tell you one additional thing. Your highly available web application that runs on Kubernetes cluster is just a static website. You think we could have just built this whole thing from a static S3 page without all this overhead? See, this is a problem that cyber experiences every day. Developers are building with the latest and greatest, but they don't understand how complexity kills. They don't think about the long-term maintenance costs. This is where we need to partner with the IT organization to change things now if we don't want to spend decades of remediating this and begging for additional resources to analyze threats. Okay, so now that we know the problem and what it looks like with regard to complexity, how do we solve it? Our first step in fixing this problem is to standardize. Just think of the following. How many different Java platforms should we support as an organization? Have you ever counted? Should it be 30 variants? Remember, each time we add a variant, somebody has to maintain all of it and involve security to see if the new variant passes all the cyber quality checks to say this software is secure. Now, if you use one that's already been blessed, you can start at a higher level and just focus on the custom code. What if the answer to how many variants we have to support is 3? 2 variants that you host internally and one that's hosted for you on AWS Lambda. That seems more reasonable. And if you're not familiar with AWS Lambda, Lambda is a compute service that runs your code in response to events and automatically manages the compute resources. If you run Java, Go, Node.js, C#, Python, or Ruby, then you don't actually have to worry about creating a web application. You just need to bring your own code. Think of all that time you just saved. That wasn't enough. Doesn't cost you anything unless it's used. If you host a Java web application on EC2 server in 2 different availability zones across 2 different regions, you have a minimum of 4 servers costing you by the hour. However, with serverless, you only pay for what you use when you use it. So it can save you a lot of money, and that minimizes financial complexity. Are you ready to stop dealing with patching and configuring operating systems and runtime environments and application servers and web frameworks by standardizing on something that already went through all those security checks? Our second option towards solving complexity is to minimize the problem. As we mentioned before, the more technology you throw at the problem, the more you have to support. Do you want 75 megs of applications that you need to maintain, or can you minimize the number of dependencies down to 5 megs? Do you really need the complexity of a Kubernetes cluster? Could you use an S3 bucket for static code and a Lambda job for dynamic code? Could you build a web application on a SharePoint site without coding at all? When thinking about technology minimization, think about minimizing support costs. How much do you need to spend on development hours to keep something compliant and secure? The more you can minimize here, the more resources you keep for your other primary initiatives. Third thing to think about is automating a problem away. For example, do you really want to manually log into a machine and say, install the latest security patch? What if you had to manually do that for 200 different machines? That'd be pain and pretty annoying. Now enter the world of scripting and DevOps. There's a lot of tools like Puppet, Chef, and Ansible that allow developers to write commands like yum update -- security. A simple command will install the latest version of any package that includes a security update that's not already installed on the system. Now remember, as a CISO, you probably aren't the one writing these scripts, but ensuring the developer population is automating problems away, such as patching, can be a key mitigation strategy against complexity. Now here's a pro tip. If you automate patching, be sure to automate testing as well. You don't want to just build a process that breaks your applications faster. Start by figuring out if the new patch fixes or fails by testing it first. And if you can quickly determine if it fails, great. Use that knowledge to avoid availability issues. Remember, smart CISOs understand that automated tests minimize complexity and routine problems that come from faulty software. The last way to minimize complexity is listening to and acting on feedback. Go talk to anyone who's a developer and ask them what tasks they spend time on. It's a lot of steps, or it's very complex. Ask them how that issue could be fixed. I'm sure they'll come up with something specific. Now, ask that same question to 10 other developers. Are you starting to hear any common threads, themes, trends among these answers? And if you do, write them down. Then ask your developers, why hasn't anyone fixed this problem before? Is it because it's too expensive? It's not a priority? People just don't know about it? You need to understand why this might be difficult. And once you do that, you can find a lot of unique opportunities to make the development shop a better place. If you act on those insights, developers will appreciate how you made their life better, which isn't something they're used to seeing from the cyber and the security people. It's a great way to win the hearts and minds of developers who come back to help you as a CISO time and time again. Well, I hope you appreciate this episode on how complexity can mess up your organization and really kill a whole bunch of initiatives you might have in terms of keeping things secure. And we don't want to make this episode overly complex either. So we're going to wrap it up early. How's that? But to recap, Think about the toil that developers have. Think about the ways that you can minimize the technology debt and lower the long-term maintenance costs in IT. And if you do these things, then you're going to start acting like an experienced CISO who can transform a company for the better. Well, thanks again for listening to CISO Tradecraft. If you find this episode helpful, leave us a comment on LinkedIn or on YouTube or wherever you get your podcast. We at CISO Tradecraft also appreciate when you share our messages with others, so go ahead and pass around where you get your information to other folks. Remember, there's a lot of software out there that we need to simplify. Thanks again. This is your host, G. Mark Hardy, and until next episode, stay safe out there.